Yeah, thank you very much. It's nice to be back. My name is Ole von Seelen. I'm the CCO of trinckle, a company here from Berlin, so it's a home match for us. trinckle is a software company, for those of you who don't know us, focusing on the automation of design processes. So our clients use our software to streamline and automate as much as possible of their designing processes. And we do that in very different industries, from medical over industrial to end consumer goods. Today it will be all about industrial use cases, more precisely for production. And I have been on stage here a couple of times already. I always manage to get back here because I bring fantastic customers with me, and that makes me come on stage again. So I would like to hand over to Job, and Job, you can introduce yourself really quick.
All right, so first of all, my name is Job van Sande. And before coming here today, I was talking with my grandfather-in-law, and my father-in-law, I'm sorry, he's not that old. And we were discussing, so I'm going to Berlin, I'm going to present about the adoption of 3D printing within ERIKS. And he said, so did you know that when I was about your age, or even a bit younger, we introduced a photocopier in our insurance bank. And he said, so the machine was as big as a room. There was this expert who was making the photocopies, and each of these photocopies we had to dry and before we could actually use them. And I started thinking, that's perhaps a nice metaphor, because, you know, now it's very simple. Everybody can use it, and, well, the photocopy that comes off of it is very easy and ready to go. So this is, I think, really the metaphor of perhaps where our industry is going. How can we make this bridge to this next group of users that are not engineers, that are not that expert at the photocopier, but are able to reap the benefits of 3D printing? So my name is Job, but you already knew, and I'm working for ERIKS. It's a specialized industrial service provider, so it basically means we make components, or we make, for example, assemblies, or even larger ones, how to make production facilities and production lines work better, and also how to make projects run smoother. And that's also why our motto and our mission is to really let's make industry work better. This is also why I'm always out there to really look at technologies like additive to help with this motto, to really help with making this industry work better. And we have been applying additive for the last 10 years. First, really with seals production, so that we didn't have to make a mold. We made prototypes. Then afterwards, really with jigs and fixtures, and now we're also in end parts. And we do this for various departments, not just for plastics, but also in the realm of flow control, safety and tools, as well as in power transmission. So one of the things that really intrigued me, I've been now busy with this topic of 3D printing, additive manufacturing for about 7 years. And what really intrigued me is always how it still takes quite some time to really master this technology. So how you can mitigate for the shortcomings, but also really make sure that you really utilize it for where it really works best. So having the engineers really engaged with this technology, ingraining it in their daily processes, and really thinking about how to use it next has been quite the journey for them. But there's another journey that's going on, and that's, of course, the company, where we are with 5,000 people, of which more than half is sales, and a lot of distribution and production as well. And how do you adopt it, for example, in a larger company? This has been also quite a journey, where we first had little islands where we were doing some printing. That became a central team, really, pushing hard for adoption. And eventually, we really chose for a community approach, where we had many printers scattered around, and people were really adopting it and in their own departments. So I didn't expect this myself, but jigs and fixtures has been one of the key drivers of the adoption within our company. So we first came from prototyping, and then we really went to jigs and fixtures. And I think it's also a nice way and a nice blueprint of how to ingrain this in your organization. Not just from the fact that jigs and fixtures can really help you with the efficiency of your processes, so really already giving you that efficiency benefit. It's also a very tangible result, but it's also a tangible result to many different groups in your company. So this is the engineer, but also in the production manufacturing, also with quality control. And for the people that really love numbers, the efficiency, of course, really helps with the people in continuous improvement or in finance. So it really tags into different parts of the organization, really helping with this adoption. So we're finding them everywhere. And we're also not really particularly focusing on one or two, but we have assembly tools, we have machine fixtures, welding tools we're experimenting a lot with, and we're making them a lot as well. Shot blasting tools so that you cover off areas, but also safety jigs. So there's many ways how we basically apply it. And I want to show you one of the latest examples. So it's this one, and I will have one of our engineers do the talking for me.
So this is a small jig that we made, and it's to help the people in our production facility to assemble the parts together. It's made out of a motor and an electronic component. As you can also see, this electronic component sticks out a little bit, and whenever they would assemble it together, it could flip over to the side because they have to apply a small amount of pressure on this side. So by making this jig, we made their job significantly easier for them. And where they will be struggling with getting all the parts assembled, they can now do this in maybe 1 minute instead of taking 2 to 3, because they would struggle with keeping the parts aligned with each other.
So as you can see, I mean, it doesn't look too fancy, doesn't look super sophisticated or high-tech, but it really works. And the thing is for us was, okay, so the potential of all these jigs are there, so why don't we see hundreds of these jigs in our organization pop up? Why don't we have a lot of people engaged in this? And then we really realized that you always need an engineer to draw them, or you need to have a very good drawing, and then you need to engineer the counterpart, which takes quite some time. So how can you reduce this bottleneck? How can you make sure that the CAD design processes that are now restricting this creative process, let's say it like that, do not hamper this anymore? And this is why we chose for Fixture Mate.
Yeah, thank you very much, Job. And this combination of the potential and the potential of the technology, and on the other hand, the bottleneck of the engineering, we see on quite many of our customers. And that motivated us essentially to bring up a product which is called Fixture Mate. So a design automation software dedicated for this kind of application for creating fixtures. And there are basically two goals. On the one hand, we want to make the whole process more efficient. So we want to reduce tremendously the amount of minutes, hours you have to invest into this. So we speed up the design process for experienced engineers. And on the second aspect, it shouldn't be focused on the engineers only anymore. So we want to enable people without deeper CAD skills to design those kind of parts. We are not talking rocket engine parts here. They are simple parts, and these design jobs are quite good in hands of the people that actually need those fixtures in place. So we want to enable them. That was the target. And I want to show this on one example from ERIKS. And what we see here is a cover which has some motor and gear elements inside. The cover is meant to protect it in a rather challenging environment. So you have to assemble a couple of very small, tiny parts inside this cover. And we learned that for this assembly process, it would be great if you had two positions, one upright, like on the left side, and one slightly tilted on the right side. And ideally would be a fixture that has both positions in one fixture. You can change the position, and this little hole in the front should be accessible at all times. So that is the target for a little fixture here. So this is the end result. I hope you can kind of understand what you're seeing, because we basically tilted the position of the part, and we now have that in this rendering. We see both positions of the part in the fixture already. So quite a nice, easy fixture. And now I want to show you how we would design that in Fixture Mate. So let me talk you through this process. Remember, the ultimate goal is we want to enable people that do not have the CAD experience in depth. So this is why we bring them through a quite intuitive process from uploading a part to downloading and exporting the fixture. So I bring in this cover. I bring it into the first position and I position it in an orientation I like. And then I bring it in a second time. So I want to create the second orientation, the second positioning of this cover. So now slightly tilted. And so you guys can recognize it easily. I color it in a different color. So we have this blue and now the yellow version as well. So and now for these two orientations, I want to create a fixture, basically a nest geometry. The first thing that we do is we choose a base plate. So in the second step, I have the chance to design my little base plate here. Let's start for a moment with a 3D printed one. Yeah, so imagine the overall nest would be on one plate, even the plate is 3D printed. So the next thing that we want to do within the software is creating some support geometries holding these parts, those two cover versions in a secure position. And as you see now, we do that by dragging and dropping. There are some marker points in the user interface, so you see it's quite far away from a traditional CAD tool. It is really simple to use. So you create those kind of supports. You might think, oh yeah, but there are still these overlaps, there are still these conflicts. Bear with me for a second. Yes, that was the moment where we cleared the path, so we subtract the work pieces from the nest structure. If we hide both of those covers, you can see now the negative, the cavity that we created in those two positions, and both are held in place in the right orientation at the same time. The hole in the front is still accessible. So this would be now the version where the base plate is part of the 3D printable design. I will, in a second or so, we will jump over to another alternative. Oh yeah, before that, we still want to get a little label on top. Kind of a nice little feature that it's super easy to apply a label. There are a couple of more features hidden in the tool, but I cannot show everything now in 2-3 minutes. So, of course, you cannot only create those this rectangular boxes, you can create kind of any shape, really, but it's always supposed to be in a very intuitive way, so you have a couple of mouse clicks in the software, in the user interface. And we like these kind of designs, like the all included on one 3D printed object, but there is even one situation which we like more. We like hybrid designs of those fixtures. It's not, for some scenarios, it's really not meaningful to design everything in one 3D printed object. You would rather combine it with something that you already have on the shop floor. So let's imagine we had a perforated board on the shop floor already. So this perforated board we can use and then connect it with the 3D printed objects. What we need for that are these mounting structures, and you see already it's quite nice to place them. You just select those holes. The algorithm knows the grid that you have underlying. So with a few mouse clicks you have these nice mounting contours ready. And at the end you will get not only the 3D printed part, but also a PDF that gives you all the mounting guidance, basically. Yeah? So this is what you hand back to your assembly team, and they can print it on an Ultimaker or any other low-cost printer of your choice, and they are ready to go. So what did we achieve? Most importantly, we unlock the community that Job mentioned. Yeah, we want to enable people to use it, and they don't necessarily have to be experienced CAD engineers anymore. But even if the engineers are using it, probably they will enjoy it too, because it reduces the time of design significantly, by 80% roughly. And then if you imagine this combination, that gets really charming. Then you design it in 15 minutes, 20 minutes, you send it to the printer, you print it, you use it the next days. And even if something is not perfectly right, then you just do it again, it takes you a second day. Hey. And then you have the perfect picture. It allows you to iterate fast. And the software is cloud-based. That means you can roll it out across your organization quite nicely. You just give access to different departments in your organization, and you motivate them to make use of the 3D printing technology. What were the results for ERIKS? On the one hand, the time saving for the individual design time, it's 83% on average. In total, we enable them to create a fixture, design and print it in basically 1 day. And the software is super simple to learn. It's not that you need to dedicate weeks for education or training on it. If you use that software for 1 hour, I promise you that you can create your first fixture designs. It's really not a problem. But more interestingly, I think we should look at those use cases you mentioned.
Yeah, exactly. So if you remember the first video where we made this one, the engineer who was presenting it to us, actually he was part of the trying to roll it out team, and he convinced a colleague who was non-engineer, non-CAD user to make this jig. They did it in 2 iterations of 20 minutes. And yeah, as you can see, then I started asking him, so what did you save? He saves 15,000 euros on efficiency per year, so 7,000 of these are made, the end assembly, 2 minutes saving per end assembly, but also the first time write quality went up. So we're saving something roughly like 20,000 euros in a 2 times 20-minute cycle, so that's pretty good. Well, also, that was so motivating to that department that they kept on seeing new examples. There's now about 10 of them, so they're saving about 100,000 last year and also this year again, of course. And because they're part of a community, they started infecting the community in a very positive way, and they started finding also new examples. So it really worked. So that's the potential. And then think about the scale. So this was 1 team, and I have 10 teams with all their own printers. I have another 10 to go, which don't have a printer yet, but they will get one too as well. So that's 10 locations times the saving. The community of experts now also includes enthusiasts. So that's not just the people that can engineer, but also from sales or from production who really like to dig into this expertise and to learn more about it and seeing these opportunities. And we really took away the excuse. You know, there's no excuse not to spend 20 minutes on trying to find a solution to a problem that you have in production or somewhere else. So this really creates a sort of, it creates a positive cycle up where we can really see this is sustainable results and the community will carry it, not just 1 or 2 persons. And I think that's really important. And that brings us to, the last thing. I think that innovation power and innovation adoption really has to do with if you can make it as simple and applicable enough that you really drive this innovation home. So making it simple for a lot of users and having a lot of different applications where you can use it at. So it really works for us. So do have a look at how we do it. So me, myself, I'm not an engineer, and I also was able to learn it in roughly an hour. I find it very intuitive, but I'm always depending on a lot of people around me to also do that. So we did it working with a workshop, or for example, we can start with the videos that are there. Then we went to a workshop where you explain it in an hour, and then we took it really into the organization, and we're driving it ourselves. And the results are here, so I hope we'll have many more. Perhaps you can design some for us today, and then we'll have even more results. So that would be great.
Yeah, thanks, Job. So that would be our key takeaway for you guys. So it's fantastic that we have all the great technologies here, but it's really important that we need to keep it simple and we need to keep it accessible to the organizations. We need to bring the additive manufacturing out of this niche. We need to make it scalable, so we have to think first about enabling the organizations. That was the main point we wanted to make. We wanted to show the software live here on stage, but I was not allowed to bring my notebook on stage. It was a little bit too much of a hurdle, but you have another chance to experience it if you are interested in. There's the workshop number 2 later today, where we will show you in a couple of 20-minute sessions how to design not 1 but 2 fixtures in these 20 minutes. My colleague Damien and we will do that, and we would like to see you there, and we can then prove that the simplicity we are promising here is true and is in the software. So thank you very much for your attention.